Hello, welcome to video number 85. We're going to talk about computing confidence intervals. We're going to do one example, practicing the formula that's right here. And then we're going to switch and use our TI-84 to do this. Here we go. Here's the first example. A U.S. Coast Guard survey of 300 small boats in Cape Cod area found 120 in violation of one or more safety regulations. Give a 95% confidence interval for P, the proportion of unsafe boats. Okay, we can do this. So here's the formula we're going to use. So remember, we take our estimate P hat, the sample proportion, and we add and subtract this quantity, which is the margin of error. Okay, so we'll complete this information and compute the interval. In this case, n, the sample size, is 300. And the sample proportion, well, 120 votes were in violation out of 300. So P hat is 120 over 300, which is 0.4. That's our estimate of the true population, 0.4. So this time I'm going to include a graph on the number line. So that's P hat. And remember, just like in the Cubs project, we're going to add and subtract a multiple of standard deviations. The problem is we don't have P to compute the standard deviation, but we're going to use P hat instead. So this is going to be the square root of 0.4 times 0.6 divided by 300. Okay, so this is called, remember, the standard error. It's an approximation of the standard deviation. And in this case, we get 0.028. All right, Z star is how many standard deviations we want to go in each direction. Okay, so in order to get a 95% confidence interval, an interval that works 95% of the time, we need to go 1.645 standard deviations in both directions. Actually, I'm sorry, 1.96 for 95%. Sorry about that. 1.96 in both directions. Okay, so there are two forms to write our confidence interval. Okay, so let's try the first form. So using P hat, which is 0.4, plus or minus the margin of error. We get that by multiplying Z star times the standard error. So let me do that real quick. So we get 1.96 times 0.028. And I get 0.055. Or if we want to do this in percents, we could say 40% plus or minus 5.5%. Okay, so that means kind of what it means is we're 95% sure it's within 5.5% of 40%. Another way of saying that is the confidence interval itself. So if we subtract 0.055, I believe we get 0.35. And if we add it, we get 0.45. All right, so you're going to see this kind of expressed both ways, 40% plus or minus the margin of error, or as an interval like this. And I should be able to go back and forth from each one. All right, if I graph it here, it goes down to 0.35. I don't know how to erase that straight mark. And it goes up to 0.45, which is right here, just this much right here. Okay, so we add and subtracted the margin of error, which is 0.055, the P hat, and we get our interval. So we're 95% sure that the true proportion is in this range of values right here. Okay, so here's how we'd interpret it. We are 95% confident that the interval 0.35 to 0.45 contains the true proportion of small boats that are unsafe. So we have to state our confidence level. Okay. We have to actually state the interval, that's part of our answer, and we should state what we're estimating, the true proportion of small boats that are unsafe. So that's the pattern. Confidence level, the actual interval, and what it is we're estimating. All right, this is going to go a little quicker, so we're going to use a TI-84. So in this problem, a random sample of 5,000 Americans were asked in 2008 if they approved of George W. Bush as president. 25% of the people said yes. Okay, that's not too high of approval rating. construct a 98% confidence interval for the proportion of Americans who supported Bush at that time. Okay, so what you want to do is press Stat, then Test on your calculator. So press the Stat button. We've used Edit and Calc pretty often. And now we're going to use the Test menu. So press Stat, Test, then you go down to option A, all the way down. It says 1 proportion Z interval. So this is the one we're going to use, 1 proportion Z int. All right, X, the number we enter for X is how many people responded favorably. So we can't enter P hat, we have to enter the actual number. So 25% of 5,000 is 1,250. That explains that number. N is the sample size as always. You enter the confidence level you want, 0.98, and then you hit calculate. And here comes the interval, that easy. So the confidence interval is between 2.24, if we round, and 0.26. That's a pretty narrow confidence interval. It's a really good interval. The reason why is because 5,000 people were surveyed. So we're 98% certain that the true approval rating of all Americans is in that interval. Now, we should be able to go back and write it this other way. P hat plus or minus the margin of error. Our calculator gives us P hat, and it was actually given in the problem, so it's 0.25 plus or minus. The margin of error we got to figure out. The margin of error is half of the interval length. So if I take the right endpoint, subtract the left endpoint, and divide by 2, I get the margin of error. It's half of the distance between those. Because P hat is right in the middle, we add and subtract the margin of error to get those. So this is 0.2 over 2, which is 0.1. I'm sorry, 0.02. So 0.02 divided by 2, which is 0.01. 0.01. Okay, so it's 0.25 plus or minus 0.01, or we could say 25% plus or minus 1%. Okay, all right, so the calculator makes it a lot easier. All right, here's another example. A random sample is taken of 400 males who are in the labor force and under age 25. 60 of them reported that they were unemployed. Find a 95% confidence interval for the true proportion of unemployed males. Okay, this time I have my simulator here. I turn it on. Okay, so I'm going to show you how to do this. So you go Stat, and we'll go over to Test, and go down to option A, way down there. 1 proportion Z interval. Hit Enter. This time it was 60. 60 responded favorably, and this was out of 400. And we wanted a 95% confidence interval. So let me change this to 95, then calculate. So we get 0.12 to 0.18. So 0.12 to 0.18. That's our interval. And our value for P hat was 0.15. So we can say that this was 0.15 plus or minus. I got to figure out half of what this interval was. So we can do 0.18 minus 0.12 divided by 2. You get 0.06 over 2, which is 0.03. So our margin of error was 3%. Okay, so we could say 15%. And the margin of error is 3%, or plus or minus 3%. Okay, so if we were to interpret this, we'd say that we're 95% confident that the true proportion of unemployed males in that age group lies in between 12% and 18%. Okay, this time it says check the conditions. The data values must be independent. Well, it was a random sample of 400 males, so we're pretty sure the males don't influence each other's employment. It was a random sample, so that's good. 400 males is far less than 10% of the workforce in that age group. And we got to check NP greater than 10 and NQ. Okay, so 400 times P. Well, we're going to use P hat for this. So 0.15, and I believe that's 60. And then 400 times Q, which is 0.85, actually is going to be even more. It's 340. So this is true also. So this means that the normal curve is valid and our confidence interval is valid, right? If those conditions weren't true, we'd have reason to question our confidence interval. All right, here we go. It's time for the journal assignment. Okay, in a random survey of 1,000 large corporations, 250 said given a choice between a job candidate who smokes and an equally qualified non-smoker, the non-smoker would get the job. Okay, so you can use your TI-84 to construct a 95% confidence interval. Go back, tell me the value of p hat, the margin of error, and interpret the interval. All right, good luck.